this time I'm digging into a smaller problem, which I'm working with right now, together with my colleagues, about incentives. Can we get rid of that one? Yeah. Incentives for research, and it's a really interesting thing to give money for publications. For example, in Turkey, I think they give money for each publication in a ranked journal. It's quite a sum. The same in Spain today. Bulgaria as well, no?
No, China.
China, of course, China, yeah. But there's a lot of rumors about China, so I don't want to go into China. We don't know what is really happening there, but we know some about what is happening in our countries. Sweden has had an incentive system for universities, not to the individual. That is a difference, of course. You give money for publications to a university, and they get, for example, 13% of all the money that goes from the government directly to universities. This creates a sort of strategic problem for the university. How do they act in order to be able to grab as much as possible? Is it going for high impact publications only, or should they try to publish as much as possible in all places? And what would be the best strategy? That is an interesting question, I think. And we see from different countries that there has been a sort of move towards going into the direction of that productivity, high productivity at the international level is sort of doing harm to science. If you publish too much, that will be harm for your career, more or less. And I think that is a very strange thing. It doesn't really fit with my prejudice, and maybe we should dig into that a little bit more. But this is a publication, the title of a publication that was in Nature 2002 by Linda Butler, a researcher at Australian Research Council, I think, or she was financed by the Research Council. And she said that the list of published paper is no measure of value. So the Australian system that was introduced in 1996 sort of didn't produce anything good. It rewarded quantity, not quality. And that was what she was after. This is a picture of the paper in Nature, and we go further to the figure. What she showed in her paper was that if you then divide all the journals in this case in Science Citation Index, so only natural science and physics, chemistry, and so on, by journal impact quartiles, you would have you could see then the development over time from the 4-year period 98 to 85, and 5-year periods, sorry, up to 99 then. And she puts a line in 1991, 92, something, 91 we guess, as you see, the introduction of publications collections. So already the case that research councils and universities sent publications collection, list of papers that they have contributed to to the ministry or the government or the Ministry of Education created a sort of incentive for researchers to publish more. This is what she says here. Introduction of publications collections. But what was disturbing from her point of view was that what you see is quartile 1 has an increase. Quartile 2 has also an increase, but quartile 3 and 4 has the highest increase. Sort of this is the share of all publications in Science Citation Index. So at this time it was maybe 4,000 or 5,000, at most 4,000 or 5,000 journals. The implications of this was when you introduce anything like this, you introduce a sort of incentive that makes the researchers to think fast and to make it as easy as possible. So if you publish in the low-ranked journal, you will probably make it easier for yourself and grab the money for the university in this case, because Australia used a system where the government paid the universities. So it's a very sad view on how researchers act, how they think, and how they react on incentives. They are like animals. Just don't take anything of no responsibility for quality. So of course, there are room for questions here. Is it really the case that an output-based funding system, which counts papers, will result in a decline of quality? And how do we measure quality? Do we find perverse effects of such a system? And what would perverse effects be? So I will go into that a little bit and discuss, and then I will also show some results from Lithuania, which can throw some light on this discussion. I'm not sure that it will answer your questions that you introduced, but I think I hope it's interesting questions. So in order to be able to say anything about this, we had to do some sort of replication. We had to do it all over again to use more or less the same data. But we didn't get the data from Linda Butler, really the data she used. That would be possible, but it's not really interesting because she used a database, Science Citation Index, nowadays hosted by and created by Thomson Reuters or a Chinese now, we don't know. It's Thomson Reuters has sold the database, they say. I don't know. I hope the one who bought it will keep it as it is, because I'm very fond of it. So we do a replication using the same data, and we also introduce, of course, some new indicators of quality, because journal impact is maybe not the best way to measure quality, because this is quality of average publication in journals, and that is it doesn't tell you much about what the quality of the Australian papers in those journals. Of course not. There are a lot of other quality dimensions that you could, for example, you mentioned some of that, sort of having some relevance for the business would of course be of interest to investigate upon, but we will not take care of that in this investigation, in this work, not at all. That would be a real challenge. So why do we do this? Well, we have to remember that knowledge is tentative and not solid. And until it's falsified, we tend to believe in it. If we try to falsify, that would make the Linda Butler claim much stronger. It would be a second analysis with the same data, and that would be very good then. So of course it's interesting to do it. But as we know, it's very seldom that researchers, especially in the social sciences, do these type of replications. We seldom go into others' work because it's sort of, we tend to think that it's private property, and data is private property, which is not really the case. And that is sad because journalists and politicians, they often believe in single results. We don't have the same situation in the sciences, in the natural sciences at least, where a result always triggers new investigations with the same data or with competing data. The trouble is that one outcome becomes the truth. And this is really the case with Linda Butler. This has become the truth, that researchers who publish much do harm to science. And it's much smarter to be prudent with your publications and publish as little as possible in the top-ranked journal and have a very high score in your citations. As it is today, we have a number of different initiatives where they're asking for responsible use of indicators, and the Linda Butler paper has a huge impact in that discussion. So it's for example, the Leiden rules for bibliometrics include a skeptical view on productivity. It's also something that has touched the political community in the academic community and the political community in the Netherlands. So the SEP has abandoned productivity as a criterion for quality in the national evaluations. And Linda Butler has also become sort of a name in the salami slicing discussion, that you do harm to science by splitting up your publications in as many as possible. But when we look into it, the underlying mechanism of Butler's findings are quite unclear. And if other empirical evidence is lacking, replication is really important. So what we need to understand is we need a sort of theory of behavior in order to be able to also explain why things happen. And if we look into what we know about motivation and commitment of researchers, so it's nothing there who indicates that productivity would be something problematic. So normally, if you are if you're in the research business, you want to do results, you want to produce, you want to go further, you want to take another step, you take the next step, you want to collaborate with this one and this one. So you want to spread the word or your ideas all around the world. That is sort of the basic idea. For the reference here, Pels and Andrews did some very huge investigations in the 1960s on motivation and how researchers became productive and published that in books. Van der Weyden and with my colleague Peter van den Besselaar did some follow-up studies in last year, which also thinks that this is the case. So if we look at scientific creativity, it's a clear theory that you become creative when you have ideas, and the more you try, the more hits. So you cannot be very prudent with your ideas and your tries. You have to do as much as possible. The more you do, the more you will be able to have a hit. And that in this case, the more articles you write, it's more possible that you have high impact on these, on at least some of these. And if you only publish a few, 3 papers over a 10-year period, you have to be very, very lucky in order to have a hit. But if you publish 30, 40, 50, of course, the number of hits is more possible. And so that is Simonton, who has done this in a book on creativity in science. He's a psychologist. And I think this goes very well together with empirical evidence on quantity, the number of papers per individual researchers, per researcher, which we now are able to do in different investigations. So Van den Besselaar and Sandstrom 2015 is a study of all Swedish researchers, 48,000 researchers, and looking at those who publish top papers, top cited papers, sort of the top 3.5% it is, and how many papers do they have over the period of 4 years? In this case, it's very laborious to do this disambiguation of researcher names, but it has been possible for Sweden, and Larivière and Costas has done that in a parallel on I think global data. So looking at top 10%, then field normalized, of course, papers, and you see that there is a clear trend that the more you publish, the more papers you have in top 10, and it's the same for top 3.5 or things like that. So I don't go further into that data. I can explain it more. If you look at this is then top 3.5%, and you do this by field, you see that there are some differences. On the right side, you have the scale for natural science, life science and medicine, chemistry, physics, engineering, and psychology, education, environmental and geography and agriculture. And on the left side, computer science, mathematics, humanities, and social science, politics, and economics. But the trend is quite clear for most of the areas, although you find in humanities a downward trend, and that is because I think also in computer science and computer science they have a different audience. So when you become more productive, you also tend to publish in other publication types of publications, books, reports, governmental investigations, and things like that. So you don't end up in this case in Web of Science, Arts and Humanities Citation Index or Social Science Citation Index. But you have to be productive, and in this case we work with different productivity classes. You have those with one paper. Let's see if we can. Of course, so the dots here are for different productivity classes. 1 paper, 2 papers, 3 and 4, 5 to 8, 9 to 16, 16 to 32, and 33 and more. But when you have 33 and more, you have clearly an advantage, and you produce more high-cited papers. And what is the thing with doing high-cited papers? The top 3.5 in this case. That is, of course, things that changes the research front in that specific area, in this specialty. That is what is really important. If you want to contribute to science, you have to be in top 10% at least. If you want to change it, you should be in among the absolute best. And so of course in this case, we see that you have to be very productive in order to do that. Otherwise, it's just by chance. So let's now go to what happened in Australia during the 1990s. As in many other countries, there was a decline in production, and sort of things went down. At least also in Sweden, we went from a high general impact level to lower levels. That depended partly on that the Web of Science database, or ISI as it was called at that time, is of course a living material. It changes all the time. It went from 3,000-4,000 journals covered and indexed to maybe 7,000-8,000. And of course, in that process, they included more countries, and it became much harder to keep your percentage of publications in the database. So of course, when China started to go scientific, or whatever we call it, they also, Web of Science started to cover and index a lot of Chinese journals. And it became sort of a revolution inside the Web of Science from 2000 and onwards. And 2007, they included a lot of new regional publications, journals, also Lithuanian, I guess. Yeah. So, in order to meet this sort of crisis for Australian science, as it was called in some reports, government started to discuss a new funding system that was announced in '92, but not implemented before 95-96 in that budget. The problem then, because when Butler then continued with her analysis and published in a very influential article in Research Policy in 2003, and also a chapter in an edited book in 2004 about bibliometrics, what happens when government starts to give incentives? What happens with, And in her claims was that, yeah, quantity goes up, but quality goes down. You will have a lower average impact, and she showed that using sort of national science indicators, which was a part of Web of Science that was then available for many universities at that time. But something that was introduced in 95-96, of course, it's very hard to see what would be the effects very soon after 95-96, because she didn't cover the period after 98 in her papers. So we start to investigate upon that and use then a similar database. It's called Insights today. We have very much more indicators and new indicators. We have a longer period because Butler's analysis stopped in 1998, which is crazy for something that started in 1996. We use actual citations, not really what would journal impact factor then, actual citations. And we have just submitted a paper then to Journal of Informatics on this. It's gone through the first round of peer review. Perverse effects of output-based research funding, Butler's Australian case revisited. So just have a look at the timeline. And I think that's important. So if you write a paper in 91, it will be published in 93. If you write a paper in 95, 96, you will have that published in 98, 99. And of course, you won't have figures of citations before first 2001. So timeline is quite important here. So the new, what we call new analysis then. Output goes up, that's really true, same as Butler. But the same holds for top 10% cited papers, which I said was a very important indicator, which then indicates that we have an increase in quality. And this holds whether we compare to the world or if we compare to a more relevant comparison, Australia and the Western countries. So let's have a look at then Australia in relation to world average. This is the line for papers, which really goes up after this, and this is then the right scale to the right, which is the percentage of papers from Australia. But it went down in that period because the database were changed, and quite a strong decrease in impact, which is then in this case top 10%. But that changed around this time. It's not here. We don't see a change, but in 97, maybe from 97 to 98, 99, and it starts to go up. And Australia has kept the more or less the same system, although it's more like the UK system today. But that started in after 2007, I think. This is the more relevant comparison, where we compare to a set of countries. Also, in this case, you don't see the same dip because other countries are not involved. This is Sweden, Netherlands, Germany, France, Italy, and European countries. Japan is also included. there is a change here from the dip in 96, 97, and that changed. We don't know whether it's really the incentive scheme who changed this. Of course, it's impossible to say what is but we just describe what happens and can give another picture than Butler gave. And you see when you compare to the different countries involved here that Australia managed to stop the decline, and not many other countries could do that. Although there are, of course, some very special countries who goes in the other direction. Belgium, for example, and Sweden was another country with the same type of problem, which hasn't been able to change things before 2010, 2 years after the introduction of the incentive scheme in Sweden, which was based on something that I did in 2007, still in use. Japan is of course the trouble in this case, and this is top 10%, of course. Then. So if we look at it from the empirical point of view, how is it? 10 minutes, yeah. Both output and quality goes up. Impact is actual impact is actually going up, and this is contrary to and contrasting to Linda Butler's analysis. So, to do much in science is not harmful to the impact. We find the same effect in other countries, for Norway and for Denmark, and it turns out that it doesn't matter that much how you construct the incentive scheme. I have the impression that the system in Lithuania is very complicated, but the only thing that it should take into account is that if you are productive in humanities, it's not the same as being productive in medicine, of course, or physics, because that you have to do some field adjusted production for that, and it's very simple to do that. But if you do that, you can actually give incentives to individuals or to universities on a very simple manner. We find also that from theoretical point of view, we would expect that to happen. So it's not really going in the wrong direction. And we don't have any evidence of perverse effects of output funding. If we look at Australia and divide journals into international ones and national is blue here, so they continue to publish in national journals, but the growth of Australian papers is in international journals. More interesting is that also when we look at page length, which is the only way we can sort of find something that we can illustrate salami slicing. Salami slicing would probably implicate that you have shorter papers and try to publish things that would normally be 9-10 pages, maybe for 5-6 pages or something like that. Fewer figures, fewer tables, and things like that. And we know by other investigations that the more tables, the more figures, the longer the paper, the higher the impact also, shown by Per Seglen, the Norwegian. But if you look at all these, the same countries, so Australia is on top when it comes to paper length in 12 journals from different areas. Those where there is a substantive number of publications, of course. Japan is then, I guess, from language, for language reasons, they try to have shorten it as much as possible. So that is an aspect. So we should be very careful when we talk about and use bibliometrics. If we don't have an understanding of this, the context and underlying mechanisms. So if we have on the one side theories that says that creativity in science is like this and that, and motivation. So motivations from scientists is very important, and it would be distrustful to the whole scientific community to say that they try to cheat all the time. It's a very small part of the community who try to cheat and make the easy route. Normally, you play it fair, and that is probably 99% of the population. So we ask for a real radical redirection of the discussion on these issues. Now some minutes for Lithuania, and to just illustrate. Are you worried now? Yeah. I happen to be that as well, but I'm not sure that you should be that. I talked about field-adjusted production, and because we have, with the help of Eleonora, or Eleonora is the driver of this project, we do sort of harmonization of organization names. So you really can say that the publication from Vilnius is a publication from Vilnius. And field-adjusted production makes it comparable between universities in this case, because if you are in a field of sports science, for example, you have a level of productivity, a normal productivity. And in this case, it's compared to and the base is all Nordic countries, sports scientists in the Nordic countries. So I think it's a fair comparison even if levels of productivity is maybe a little bit lower here in Lithuania. And the same for chemistry, physics, and humanities, and so on. So you can actually compare because a researcher in humanities will get highly paid in field-adjusted production-wise for a publication in humanities. It might be 5-6 times more valuable than a publication in chemistry. Of course, all depends on the number of collaborators that you have. So you fractionalize and then, but you use this. So it's only number of publications here. And what is important then is this thing, core and non-core journals. The number in core journals is of importance. And those who was at the conference last year remember the core and non-core. I repeat that core is those that are in the international publications where there is a citation traffic that is really includes many countries and not only national or bilateral Lithuania and Estonia, or Lithuania and for example Sweden, but an international. So non-core journals are sort of those that are national and keeps it under that national signature. And what you see is, we hope that we've done this correct, of course, we're not sure. Someone should look into that, but that this is the increase from 2011 until 2015, so 48% increase in core journals for Vilnius over the time period. It's only 5 years, so it's quite an increase of field-adjusted production. The non-core goes down 23%. For Gediminas, it's 18% up, 40% down in non-core, you see. You have for some exceptional results. Maybe you shouldn't go into that, but there are those that go down in international core journals and goes up in the others. They are black here because they are the sinners, of course, from my perspective. So that would be you should have. If I were the rector, I would consider whether this is the right direction or not. But also you have in sports science, for example, then an interesting pattern where they have a high growth in both ends, which is of course. And if you take this, there are very low figures, so you shouldn't draw any conclusions. Just to repeat now, what is core and non-core? What does it stand for? Core journals has an international scope, also when it comes to international authorship. So you have many countries in the authorship. They have a sufficiently large number of citations and references to other core journals. So they relate to the other international journals. Citation traffic I mentioned. A number of Lithuanian journals do not meet these conditions as it is today, of course. But the process is underway. And formerly we had a figure last year that 65% was national authorship. It's now going down to less than 50, and we see that there is a process. So there is a relation between the national journals and the international ones, and in the system. It's not that national journals is something that you have in your back package and becomes very heavy for researchers. It should be something that is a stepping stone towards international authorship and is of course of importance for younger ones. If you don't have the idea that you have to publish in Cell, Nature, Science, and so on, which is impossible. This is what happened in Turkey. When they had this type of incentive scheme, that if you publish in those journals, you will have a huge amount of money. So what happened? Yeah, the Turkish scientists submitted 100% more. I think that it's not enough, but many papers, and that became something that Science and Nature had to take care of, because it's a review system, and it made the stress on the review system. It's also the same for China and Spain, of course, which is crazy, because the number of published papers in Science and Nature from Turkey didn't go up. China. This is Paula Stefan. Yeah, Paula Stefan. Yeah. And if you look at core, non-core in Lithuania, you see that it's going in the right direction overall. This is all universities then, and all types of organizations. And if you then have it percentage-wise, it's going from 67% non-core to 47.4%. So that's a very good trend. And if you count it in citation-wise, so you have field-adjusted production times the publication points, where publication points is if you are in top 1%, you are given 100 points. If you are top 10, 10 points. Top 25, 4 points. Top 50, 2 points, and so on. It's a way of keeping an integrated indicator. You also see that it's going in the right direction. From 40 to 65% of publication points are today in core journals. And if I look at the salami slicing, we also find that it's actually going in the right direction. The mean number of pages from Lithuanian authors is actually becoming higher. So it's very positive news, I would say. Thank you very much.